So for one mean hypothesis t-test, there's two different types of problems that we're going to look at. There's one problem where you're given sample data and the other where you're given sample statistics. You can use both methods to solve your problems. So for this example, example 1, we're going to be using sample data. For the next example, example 2, we're going to be using sample statistics. So here's example 1 using data. Statistics students believe that the mean score on the first statistics test is 65. And a statistics instructor thinks the same thing, that the mean score is 65. He samples 10 statistics students and obtains their scores. He performs a hypothesis test using a 5% level of significance. The data are assumed to be normally distributed. So, what test are we going to use? We're going to use a t-test because we weren't given a population standard deviation. If you go back and look at that first slide, all I was given was a population mean, a set of data, and a level of significance. No population standard deviation was given, so I'm going to run a one mean hypothesis t-test. State the null and the alternative hypothesis. So the instructor believed that the mean score was 65. So because is the same thing as saying equal, I know that my null hypothesis is the mean equals 65. The alternative is that the mean does not equal 65. So is it a right-tailed, two-tailed, or left-tailed? It's a two-tailed, and the reason I know it's a two-tailed test is because the not equal sign is in the alternative. Is the population standard deviation known, and what is it? Again, the population standard deviation is unknown, so I run a t-test. So now I need to start putting the data into Minitab. So there's slides behind this that show you how to do that, but I was going to manually show you how to do this with Minitab. So I click on Minitab, and if you look here, I've already put my data into C1. All I did is I typed it in going down, kind of like if you use Excel, it's the same principle. I labeled this as grades just in case I get more data. I want to make sure that I label everything so I'm not confused to what is in each column. So I'm going to go up to statistics, basic statistics, and go to one sample T. So since I'm given that it's one or more samples in each column, I select that. If I was given standardized data, I would click that and it changes the output. So I'm going to do one or more sample. I click in this box down here, and for here on the left, it populates my first column, C1 grades. Because I've labeled it as grades, I see which one it is easily. I click on it twice and it populates in this box. I'm going to click Perform Hypothesis Test, and I'm going to put 65 in here. Again, 65 was the population mean. Click Options. I put 95. Remember, my level of significance was 5%. So a level of 5% for the level of significance is the same thing as 95% for the level of confidence. I click this down arrow. I'm not using a less than symbol in the alternative, and I'm not using the greater than symbol in the alternative. I use the not equal symbol. Again, I'm using the exact same sign that's in my alternative hypothesis. I hit OK, and I hit OK. And up here, it populates everything that I need to know. So from my data down here of grades, I know that I have a sample size of 10. The mean of the grades, or the average of all those grades, is 67. The sample standard deviation is 3.2. Again, this is not the population standard deviation because I got the information from a sample. If I look over here, here's my confidence interval, and again, we talked about that earlier in this module. So I've done my null and my alternative hypothesis. My t-value is 1.98, and my p-value is 0.079. I've got all the information I need so I can go back and solve my problem. So if I skip down here to all the information I got, I know that my t-test statistic was 1.98, and I know my p-value was 0.079. So I need to figure out what to do with that p-value. So I'm going to compare it to my level of significance. So p versus alpha. 0.079 is greater than 0.05, so I fail to reject the null, which means I'm keeping the null. So because my p was larger than my alpha, I'm going to keep the null. So remember, my null was that the mean equals 65. So I can conclude at the 5% level of significance, there is sufficient evidence to say that the mean test score is 65. So again, because my null hypothesis was true, the mean test score is 65. So the students were right and the instructor was right.